My project, Operation Fireline, utilised the iterative process to develop it from its simple geometric top-down shooter concept into the well-scoped low-poly build released with help of numerous playtesters, inspired by the works of Taito's Space Invaders and Konami's Metal Gear Solid. My top-down shooter prototype was basic in scope but functional in results, but also led to necessary changes to be requested by my playtesting team, where major requests included bosses, aiming at the mouse position on screen, homing enemies using Unity AI known as NavMesh, power-up abilities, and a weapon that deals area of effect damage, AoE, as well as constructive criticism such as the gameplay being linear, uninteresting, and overly predictable. Iteration 1. Weapon updates. This iteration was primarily aimed as a heavy change in visuals, while also doing some light gameplay changes. This was completed through adding the ability to switch through weapon types, which all change variables through calling voids after doing a check through 2 different switches. These variables being fire rate, capacity, damage, and weapon model. These weapon models are being taken from 255 Pixel Studios' Polygon Weapons asset package, which are switched in a script that was made in through a hard-coded amount of weapons, making my system static and not modular. Weapon switching added a replay element to my game, as strategies could be made to deal with the waves. Iteration 2. Shopping implementation. This iteration was an attempt of a self-coded shopping system, which was buggy and static. However, it was the basis on the fixes introduced in Iteration 1, most notably through transferring power-up abilities from being scattered across the player controller, weapon controller, ammunition controller, enemy spawner, and game manager to all be handled by a single script, known as the power-ups controller, or PUC. Iteration 2.5. Shopping and post-processing. Iteration changes are usually unnoticeable, as most don't implement both computational overhauls and visual changes for high impact. This shopping system utilizes countless public voids to be used as actions for pressing Unity UI buttons, to close and open numerous UI images as the pages for my system. This system allows the purchase of 3 major categories: weapons, other than the pistol, power-ups, which include abilities such as increased speed, increased health, unlimited ammo, invincibility, and double damage, and ammunition. These all require cash, which can be collected from taking out enemies or between waves from dropped coins. This iteration also includes the implementation of the weapon UI, which shows the player their available weapons, each of their firing type variables, ammunition types, and their names. The shop system also used a different switch which allows animations to play when purchasing from the shopping system. However, the shopping panel and the pause menu both use time.timescale equals 0, which freezes time for all objects within the game and makes animations impossible. To fix this, some voids were implemented into my enemy spawner script, which finds all enemies or boss prefabs in the scene and disables their scripts to stop their movement and pathfinding, so the player is unable to die when the player is unengaged. The final change made in this iteration was also the implementation of Grenade Launcher, a weapon that launches projectiles that deal area on effect damage upon collision with any other game object within the scene. This damage does not affect the player. Iteration 3. Modeling settings for release. The final iteration was for the implementation of my playtester requests, mainly implementing player aim to the mouse position for variety, as well as usage of different models for the player, enemy, and boss respectively. This was implemented through having my playtesters answer some surveys I sent out. One survey for what model the player should be, which was chosen to be the cowboy model by Vertex Modeler team, as well as options for the enemy model, which was chosen to be Robot Kyle by Unity Technologies, and the boss object, which was chosen to be the human character dummy by Kevin Iglesias, as well as asking the playtesters to choose the color of the boss, which was chosen to be red. These options required a settings menu, which exists in the first scene of my game, and uses a singleton that travels between scenes to hold booleans for these settings, and change the player model. The cube of yaw for low, and the cowboy with animations for high, as well as the enemy and boss models. This also required changes in material.color in all renderers for the models, to keep the readable effects that were in the earlier cube models, which makes an array of the renderers and in the children of the models, and changes the renderer automatically when called for. The final change for this iteration was a re-implementation of post-processing, which contains film grain, which makes everything have a hazy effect while still keeping clarity, bloom, which adds light and shadow real-time simulation, where there is vibrant saturated color being used, and vignettes, which are the dark shadows at the border of the screen. This vignette that changes color for different effects, staying black for standard or no effects, red for having taken damage, and teal for invincibility, to retain readability for the different effects. The other major change in this iteration was the implementation of bosses, which instead of using linear movement in set directions that are used from the enemies, it instead used the previously mentioned NavMesh and follows the player and attacks through launching projectiles at the player, while also having higher health and speed to add challenge to play instead of linear difficulty progression of enemies spawning for corresponding wave numbers. This game, while retaining some bugs and missing features after the extensive overhauls, is still the best game I have ever developed, as well as perfectly suited for this task's requirements.